Start over then?
No, I'm not going to start over because we have too much to go through. So the people who are seeing the recording, sorry about that. We're about 3 slides in and you didn't miss much of importance. So late 1200s, Marco Polo went to China and came back, and he said that coal was better than wood for fuel. Aztecs were using coal for fuel and for ornaments. The British mines began using water wheels to pump out the water in the coal mines. In 1807, paddle wheel steamships, and there's one of the old paddle wheel steamships. I have been on a paddle wheel, a real paddle wheel on the Mississippi. They had bought it from the Army Corps of Engineers. And I went down in the engine room, and the man on duty at the time said, "Welcome to my engine room." And it was clean and spotless. You could have eaten off the floor. It was better looking than the submarine engine room. So, I mean, it was amazing. And it was around 1900. It was an old steam engine running back and forth. It was beautiful. So we had coal-fired warships from the late middle 1800s until the 1940s when everybody started using bulk oil. So this is a collier. It's actually not the collier. This is a coal-fired warship getting its coal from a tender. And that was really a dusty mess. Okay, in the Industrial Revolution, everything started to use coal as fuel because they had invented steamships and steam uh, rocking arm steam engines. So they needed a lot of coal. So they began using it for smelting. And this I couldn't find last week when we were talking about water wheels. This is a water wheel that actually it has a little flapper there to do the bellows so that you can actually do smelting. And you got the little cars at the top dumping the ore in the top, and you have the slag going out above the molten iron at the bottom, and the water wheel turns and the bellows. For mining, in the Industrial Revolution time frame, the women were frequently hauling these coal carriers from the mine, and the children were helping by pushing. The manufacturing plants were beginning to go and use steam turbines. You can see those belts that in the middle of the picture in the front. There's an overhead shaft with wheels and belts, and that's how the manufacturing machines were running. They didn't have electric things. But look how OSHA this is. The guy's barefoot on his machine there. There's no protection whatsoever. So this is another one. You see all of the overhead belts. In Gainesville, there used to be a forge here, a man by the name of Mr. Johnson, down near the Depot Park on the west side of Depot South. There was he had a forge. He could do smelting. Um, he would make cast iron. He made a lot of the sewer covers that are in Gainesville for the sewers. Were you ever in there, Jack? Yeah.
You know,
Yeah. My dad used to go in occasionally because he would borrow an outboard engine from Mr. Johnson, and we would take it down to Silver Glen Springs. But this is how the factories were run. His factory had overhead belts like that, and there's a tensioning device. You can start or stop a machine. He had forges, he had lathes, he had everything you needed to run a machine shop. So the railroads, I probably should have gotten a picture of the Hogwarts Express, but this was a Victorian age steam engine for the railroad. Queen Victoria was the first royal to ride on a steam powered railroad. The UK, this is just to show you where some of the coal was coming from. In the UK, The brown areas are where the coal mines were and where the coal fields are. And in Europe, this was in Belgium and part of France and the Saar Valley down in the lower part. Um, so we're going to talk today. Generators are all the same, only the fuel changes. So you have coal, oil, natural or manufactured gas, biomass, and waste. You dump it into the furnace, it makes heat, and then everything on the other end has got steam turbines. So this is one of the things that it looks like for a coal conveyor. You have a conveyor belt on the lower left. And if it's not already pulverized, they have a pulverizer before the coal goes in to the power plant, and it creates the steam and it runs the turbines. And sometimes they have, after the first high-speed turbine goes back through the reheater and heats it up again before it goes through the low pressure turbines. And the generator's hooked up, and you have some way to cool the cooling water in the condenser, and you turn on the pump and it goes back and forth. So the coal types, we have lignite. It's a low energy carbon, low carbon content. It's sort of like mashed up peat and a little bit drier. There's subbituminous, which is low carbon content also, less than 0.5%, or less than half. Subbituminous, it looks like that. Soft coal, that was what was being used in England to create the smog. It's bituminous, over around 50% and up to 86% carbon, and it looks like that. And then we have anthracite, which was the preferred coal to use. It's got a higher energy content. It burns more cleanly and doesn't create as much smog, but it's still a dirty fuel. And that's what it looks like. It's the shiny coal. I don't know where I could have gone to pick up some coal samples, so you're stuck with pictures. The coal mines, they have strip mines, and this is what one looks like. You've got a machine that just runs around and scoops up the coal and puts it into trucks for hauling away. They're open pit mines. These are bigger facility. This guy is reaching into the side wall of the strip mine with a conveyor belt, dumping it out, and there down in the bottom, there's a front end loader that can dump it in a truck to haul it away. I do that. Maybe I did that on purpose. Who knows? Ah, a broad thumb. Oh, there it is. I was in the wrong place. So you have mountaintop renewal. This is a picture in West Virginia of coal mining, and they did a lot of that in central Pennsylvania as well. If you've ever been up and down Highway 81 and look off to the sides, you have open mountaintop removal, and they have their remediation. They're planting birch trees on the top to do their remediation. In the underground mines, this is just a cartoon to show you the underground mines. Yesterday or last week, I showed you the dual action water wheel where you could lower things in the mine or bring them up with the water wheel operating one way or the other. The top chamber there is showing a mechanized coal harvesting, dumping it in the little coal carriers. The middle one shows people with pickaxes. And a lot of that happened, especially in Pennsylvania. A lot of people came over, immigrants, and that's the only job they could get was coal mining, and nobody else wanted to do it, so they did it. And the very bottom, you've got a big device that's grinding out the coal and hauling it away. So this is one of those big devices for coal mining with a single operator doing more than probably 50 guys could have done. And we have the coal miners coming back. It was a very dirty, unpleasant, dark, and dangerous job. So transportation and storage. How do you store coal? You pile it up. And this is a picture of a power plant with the coal piled up and with a conveyor belt to carry the coal up into the furnace. Transportation, railroad cars. I showed you the Tesla fuel earlier. Ships and barges. This is a collier from back in the time when the navies were using coal-fired warships. You had to have a collier to come along with you. Now we have great big oil transports that go along with you in the Navy to fuel up the submarine, fuel up the targets that are running on oil. And I was on a battleship when we did an oil transfer by high line from uh, another ship or either from the battleship to one of the little destroyers. It's a messy and dangerous job to put a great big hose that's about 1.5 feet in diameter and connect it up and hope it doesn't leak. This is a self-propelled barge with coal. This is a tug and tow with coal. Coal slurry pipelines. Has anybody heard about that? John has, yeah, and so has Jack. This was talked about. I don't think they ever built the one from West Virginia to Norfolk, but there were trains running from the West Virginia coal mines to Norfolk, multiple trains per day. And somebody said, well, we can have a slurry pipeline and we'll have the pulverized coal and we'll mix it with some water and we'll pump it down to Norfolk. Um, I don't know if that ever took place. This one did work. Yeah, Jack. Yeah. Yeah, the what Jack was telling us, he's been out at the Black, was it at the Black Mesa? I can't see it from here, sorry. That's the coal production area. There's a slurry pipeline that went down to the Mojave power plant, and I don't know why it has an H there. It should be a MOJ, Mojave. Um, and they had that going, and as Jack just said, it depletes the aquifer when you do a well to get the water to make the slurry to send it down to the pipeline. So that's no longer in service as best I know. Ooh. Oh, yeah. So John Paul was just telling us that Florida Power and Light had a slurry pipeline in Okeechobee. And I just read yesterday the Okeechobee Lake is too full. Okay, what is the future use of coal? This tells you for the last 4 years who's been using what amount of coal. And you can see that China is really several times what anybody else is using. Uh, India is increasing the use of coal. The US is sort of constant, but slightly down. The EU is built up a little, and they have to build up a little more probably to take care of the problem with the Russian pipeline and the rest of the world. So, and these are measured in megatons. So this is just showing an ongoing list or a graph of who's doing what. And you can see the width of the US yellow there is decreasing substantially. People's Republic of China is going up by a great amount. EU is decreasing from what it started with in the 1990s. And the rest of the world is on top of all of that. So this is how much of these are in terawatt hours. So it's the output of the use of the coal. And China is way up there. They're building a lot of coal plants and nuclear plants. And you can see the US is the next lower little graph line, and we're decreasing. India is increasing, Russia is increasing. And this is just to show you what's happening in coal since about 1980, 85. Yeah. So Jack Spencer is just telling us that Japan is increasing their coal import to reduce the use of the nuclear power plants since the uh, yeah, Fukushima. Yeah, those were, and we'll talk about that next week. Those were General Electric boiling water reactors. I'm not a fan of boiling water, but uh, for various reasons, but we'll talk about that later. So this is the annual use of coal. And the down on the bottom, you can see that some of it is decreasing, some of it's about the same, and some of it is increasing. So the green and light green and white are people who are reducing their use of coal. The black is a US lot of reduction in the use of coal. And the others, you can see how that's going around the world. So the pros and cons, there's plentiful coal. It's cheap. It's safe storage, and generally, unless somebody lights a big fire, it's very hard. If you've ever used coal in your fireplace, you have to work to get it to light off, and then it'll stay lit off pretty well. Transportation infrastructure is well developed for railway and barges and so forth. Energy production technology is well advanced. It's been operating safely and efficiently for about 100 years or more. The cons, it's a non-renewable resource. It's somebody's estimate there's maybe 100 years left of it. It's polluting, mine scars, restoration of the mine scars, runoff from the mines, greenhouse gases, and it's polluting. Again, CO2 is a big product of any use of coal or anything that's burning. There are some radioactive elements in coal. And when I lived in Crystal River, when they talked about the nuclear power plant, they were always bragging that the nuclear power plant has less radioactive contribution to the air than the 4 coal-fired plants did, because there's just inherently some radioactive elements that are in the coal. You have water pollution from ash storage. That's been a really big problem from the power plants. There was a huge brouhaha in North Carolina a few years ago when Duke Energy, I believe it was, had a big power plant, and they had a kind of a storage dump near a river, and the dump overflowed and had huge pollution downstream. It's dirty and dusty in production and in use. Mine safety is a big element. Future use, gradual decrease in production and use in the West, a great deal of increase in China and some increase in India. Industry is converting from coal to gas to power plants. As I told you, it doesn't matter where you get the heat. You have a steam turbine that's producing the power, and the turbine doesn't care where the heat came from. 50 to 60% reduction in CO2 release and other release elements and pollutants when you go with gas instead of coal. Increased exploration and production to maintain the supply. China's up around 10%, India 14%, Indonesia and Australia. Australia has some huge coal mines, and their main customer is China. Okay, if you retire a coal plant, what can you do with it? Some of the components can be recycled and reused: steel, iron, building materials. The site cleanup and restoration can be a problem because you have fly ash storage, whether it's capped and sealed or taken away to somewhere else. There is no somewhere else anymore. The concrete foundations are hard to break up. Electrical components can be moved and reused. Transformer sites, they have cooling oil. We have transformers here with cooling oil. The transformers are about 99% efficient in converting from low voltage to high voltage and back and forth. But if you're running megawatts through a transformer, you have still a lot of heat. So they have natural circulation oil coolant in the transformers. If you look at some of our big green boxes outside, you'll see some vertical pipe looking things on the outside of them. That's the oil coolant for the transformers. The surface and groundwater cleanup, but some of the historic buildings are repurposed, like the power district downtown in Gainesville. When I was a kid, that was the power generating station. Okay, we'll go to oil. Surface pools of oil, all these things had kind of gone up to the surface. The oil, tar, and bitumen had gone up. So this is kind of a cartoon of what can happen when you have the gases and the oil and the oil and then the coal. It can seep up to the ground level, and that's been around all the area. The La Brea tar pit. Have you been there? I went by one time, and you can smell it before you get there. These guys were long gone by the time we got there, but it was a surface of heavy crude oil that was coming up to the surface. Ancient use of tar and bitumen, waterproofing for baskets and boats, the little carousels that they use in the Tigris Euphrates in Iraq were made out of woven reeds, and they covered them with some of this heavy oil to make them waterproof. You can use it as adhesive and binding agents, which was done in some of the buildings. Some of the Mideastern palaces and terraces have used that either for the surface to make it sort of like asphalt. 100 BCE, the Chinese were using oil for fuel, and 357 CE, the Chinese had bamboo oil wells. Okay, 18th century, someone discovered you could distill the oil, and they started in northeastern Ukraine. In the 19th century, first commercial distillation in Moravia, Galicia, France, and Poland. In 40s to 60s of 1800, oil well drilled in Pennsylvania, West Virginia, Caribbean, and Azerbaijan. 1850s, a Canadian company started refining the crude oil into kerosene, which would replace the use of whale oil, and the whales were appreciative. The 1856, the first large-scale refinery in Romania, 275 tons of crude oil. This is maybe what it looks like. I'm not sure, but it is in the Romanian oil fields. August 27 of 1859, the Drake oil well in northwest Pennsylvania, when we first pumped up some oil from shallow depths in Pennsylvania, and that's what that well looked like. But in the 1860s and on, we talked about the Industrial Revolution. You have to have lubricating oil for all of those machines that are rotating or reciprocating. And on the steamship that I went on the Mississippi years ago, the steamboat, and went in the engine room, they had little oil cups with a little drip so that every time it moved back and forth, a little oil would drip into where it needed. And it was so well organized and calibrated that there wasn't oil all over the place. It was just enough to lubricate the moving joints. So that began with the oil boom near the Drake oil field in Pennsylvania. Everybody started drilling oil wells. And then John D. Rockefeller came in and took over. Fracking, we need to talk about fracking because it's a way to improve the production of oil, gas, and the wells that they're using. We'll see about that. So we inject high pressure water, sand, and other chemicals down in and if you can yield more oil and or gas. And this is what it looks like in a cartoon. You have a well, and I still don't understand how you drill a well down and make a 90-degree turn. But apparently that's possible to do. Jack has done it. And he's going to talk to us, maybe. Yeah. So Jack says, you can do it, and I believe him because the fracking is a problem as well as a solution. So you pump the stuff down, and what you have is shale formations. And if you've seen shale, it's kind of layers of sedimentary rock. And when you can pump in something and hit it with a slug of high pressure uh, water, oil, chemicals, and whatever, you can fracture the rock, and that allows the gases or the oils to be taken out. So you have to drill down below the aquifer and get down into the shale and turn on the fracking machine. But there's fracking concerns, and these show some of them. As you fracture the shale, as you see down below, and you try to pump out some of the wastewater, but the fracking can fracture above where you want it to frack. And you have not only the oil and the gas, but that can seep through the other fractures above it and get into the aquifer. There, we've seen things on TV of people turning on the water in their house from their wells and lighting the water because it's pumping out gas as well. So there are big concerns with that. So fracking accidents in the field include industrial equipment accidents, explosions and fires, chemical exposures because they're putting chemicals down in the fracking zone, fatigued worker accidents, which you can have anywhere, truck accidents, which you can have anywhere, co-contractor negligence. You always need a co-contractor that you can blame everything for. Waste management negligence, because you have the waste. If you pump some of the fracking stuff back up, what are you going to do with it? So this is called the fraccident map, and it shows you where fracking is taking place, and it's where you would think it would be, where the oil is being produced and the natural gas. And it's all over the eastern Ohio area and Pennsylvania, where they have a lot of natural gas oil wells, out in the Midwest where they have oil and gas, and up in Canada where they have the shale fields up there that are have a lot of oil. And the problem with that was, what are they going to do with their waste, and how are they going to get the oil down to a refinery since we canceled out a part of the pipeline? Okay, oil production wells. Here's just a display of what they would look like at sea. So some of them are bottom mounted onto the bottom of the ocean or the Gulf. Some of them are free floating but tethered, and there's various kinds of tethering like that. And some are mounted on the bottom. After you create the well on the bottom, you can install your the wellhead down on the bottom, and that's what led to one of the leaks in the big Gulf crisis about 10 years ago, somewhere along in there. So these are just samples of, excuse me, how the oil wells are at sea. This is an oil rig, and we've seen pictures of those being manufactured in Norway and floated out to the North Sea. Carol visited Scotland years ago and with friends, and the friend's father-in-law was an underneath the North Sea coal miner. So he lived in Northeast Scotland, and they had an elevator down. I don't remember how deep it was, but it was extracting coal from under the North Sea. So this is another look at an oil well that might be on the bottom, and the lines go out and split out a little bit from the direct down straight vertical oil well lines. We've seen pictures of those all over the place. And this is how one of those guys works. It works kind of like the windmill I showed you the other day, where the oil, where the water was coming up for the cattle. It's got a reciprocating up and down rod, and down in the bottom, there's some float valves that allow you to push the rod down and get some oil in it, pull the rod up and send the oil all the way to the top with the rocking horse head up there at the top. This is what that looks like if you're driving around on some of the freeways in the LA area. And once again, you can smell that before you get there because they have leakage of methane and just the oil vapors. So here's the oil production in the crude oil in the US, and you see the giant rise on the far right, which I attribute, I think, to improved oil wells and fracking. So the world top producers and users of oil. US is 20 million barrels per day, the biggest producer of oil in the world, 21%, and followed by Saudi Arabia, Russia, and you can go right down the list. So the world total is about 97, 98 million barrels per day. A barrel is 65 gallons. Is that what a barrel is? Jack, you're from the oil industry. How much is in a barrel? 65 or 55? No, 55-gallon oil drums. Yeah, 55. Okay. So, but these are in barrels, not gallons. Okay, who is top producers and users? We're using, we do about 20% and we're using about 20% of it, but we're importing and exporting oil. So this is just another graph, a table. Have a look. Oil refining and end products. What you get from an oil well is crude oil, and it's really thick. There are several categories of crude oil, but it looks like that in a bottle. It's really thick. It's a bit odoriferous because it does have some hydrocarbon outgassing. The refinery products, bottled gas, we'll see it in a moment. Petrol or gasoline, naphtha, kerosene, diesel fuel, lubricants, oils, waxes, and polishes, fuel oils, ships, factories, and central heating. Some have used oil. I had an oil furnace when we lived in Maine. Bitumen, asphalt for roads and roofing. This is the fractional distillation process. All of these different categories of refined products are separable by the temperature at which they would outgas from a fractionation device that are all the oil refineries have that. So at the bottom right, you see the bitumen for roads and roofing, and the fuel oil. Now, the cruise ship that we went on to Antarctica was Regent Seven Seas, and it was the last year that they could go to Antarctica because they were burning heavy fuel oil. And now that is prohibited in the Southern Ocean all the way around Antarctica. So they would not be able to go anymore, and it would cost millions of dollars to pull into South America, have all your tanks steamed out and replaced with diesel. So not going to happen. And then a little up the chain, you'll get lubricating oils, then diesel. And many of the ships are now just going to diesel fuel because it's more readily available than the heavy crude oil. Oh, yeah. Richard is telling us that some of the big tankers are employing sail or vertical energy catching devices, and they can get something like 5 to 10% improvement in their miles per gallon or gallons per mile. Um, as you go further up, kerosene, and kerosene is what the jet fuel is typically like. It's that weight. Naphtha is, I don't know what that naphtha is. What's naphtha? Who knows? It's something you get from the oil. Cleaning fluids. Yeah. Okay. And then further up, you're going to get petrol for the cars. And then you can get at the very top of the fractional distillation device, you can get out the bottled gas. So this is about what you get out of that. A large percentage is gasoline and then diesel. Little percentage is jet fuel, and 11% is other, whatever that is. Lubricants, 1%, heavy fuel oil, 4, asphalt, 3. So here's the proven reserves around the world. You can see on the scale on the left that the really dark are the guys with the most stuff. So Venezuela, the Middle East, Canada, and the rest of the world has a lot less. So we need to be more friendly with Venezuela, I think, or maybe they need to be more friendly with us. But we have friends who worked in the Venezuela oil fields around Lake Maracaibo, and then he went to the bottom of South America and worked in the oil fields down there. Here's where oil wells are typically located in the US and California, Texas, and straight up to the left in Pennsylvania and that area. Is the oil well still working in Florida? Do you know, John?
No, they were shipped. It wasn't oil that they got here. They had it shipped and then they, what do you call it?
Refining?
Yeah.
But there was,
refined it.
yeah, but there was one oil well somewhere south of Okeechobee that they had a permit for. I don't know if that's still operating. So this is a look where some of the additional oil is produced, and so similar to the fracking map that we saw. And fracking, as you recall, in Oklahoma, they had not been having earthquakes until they started fracking. And then the earthquakes that they got were 2, 3 magnitude, not very large, but the fracking can cause displacement of the ground and localized earthquakes. But check this out. Those are the oil wells in the Gulf. And you see the DeSantis line on the right, and it goes back to all of our governors. Nobody in Florida wants any oil wells east of that line because of the possibility of damaging the beaches and tourism and so forth. Okay, refineries, just a couple of pictures of refineries. They are huge industrial complexes. None of the pictures I found showed the flaring of the methane that's produced, but they all generally had flaring of the methane because it leaks out from the processes, leaks out from the pipelines, and they and it can explode. So they flare it off with a big flame in the sky, and it's just up there with the flame running around. They're trying to eliminate all of that as part of the methane cleanup. So just another oil refinery. And this is a nighttime picture. They have lots of electricity they're using to keep the thing operating at night. This is one more. Oil transportation, how do you move it? From the well to the refinery, it goes in pipelines. These are the pipelines across the US to get oil from the wells into the refineries. You can see a big concentration down around the coast in Texas, where there's a lot of refinery, and up the Mississippi River. If you've taken a nighttime cruise up the Mississippi, everything you see on the right-hand side until you get to Baton Rouge is refineries. So this is the oil transportation pipelines. They have crude oil, petroleum products, natural gas, liquefied natural gas, CO2 and ethanol, and the total miles of pipeline. The pipeline total mileage hasn't gone up an awful lot since 2017 to 2021 because of environmental concerns about making pipelines and the leakage and other problems, explosions, and so forth. So this is the big pipeline, 5,500 miles from Texas to the New York area. And there's a lot of refineries in New Jersey. You can tell when you're in New Jersey by opening the windows to your car. But it's 3 million gallons a day can be pumped up that 5,500 mile pipeline. This is the Trans-Alaska pipeline with the insulation on it, and it has to make turns to allow for expansion of the pipeline. The oil has to be heated periodically. It's crude oil, it's very thick. And in order to keep it moving, you have to have a certain viscosity so the pumps will pump oil instead of just chuck down on the crude oil. Okay, rail cars, they're now using dual tank rail cars with an external tank so that if something hits it and penetrates the external tank, it may not penetrate the internal tank and cause a great leakage. Or if the rail car falls over, which they sometimes do. Barges and ships, this is a huge ship. This is probably 200,000 ton ship. And the size of those ships is the biggest that it'll go through the Panama Canal or the Suez Canal. Yeah, they've increased the size, the Panamax containers, but they're now running out of water and the Panama Canal is not operating at full capacity now. Just to compare that, that's probably close to 900 feet long. My submarine was 425 feet long and displaced about 8,000 tons. This is 100,000 tons or more. So they're huge. And what I don't see on the back, which I've always seen on these tankers, is no smoking sign. So these are barges. The barge on the right is a self-contained barge, and it's got a tug there to help it maneuver in confined waters. Trucks. And that's a cute tank. Let's go oil storage above ground and storage tanks. You'll see some things like this, gas stations below ground. And we had one of those at my dad's gas station, wasn't that fancy. We had an opening at the top. We could put a dipstick down and find out how much gas was in the tank and order it. Strategic Petroleum Reserve, we have in the salt caverns with the storage down below. And this is just another view of what it might look like in the salt caverns. And the Strategic Oil Reserve is down from 650 million barrels to about 405 due to COVID and inability to get the oil that we needed during that time. And I haven't heard anything about refilling it. Petroleum reserves, we looked at those earlier. Who's got the petroleum reserves? Not us. Middle East, Venezuela. So this is just telling you who's got what. I'm just going to race past that. We're way down on the list somewhere. Number 11. Excess capacity storage is when the production outpaces the need. The most expensive storage is above ground tanks, barges, and idle ships. Sometimes you can't turn off the refinery and you have to put the oil somewhere. So widely distributed sources of oil, easily transported, non-renewable environmental damage throughout the production and distribution, refining, distributing leakage. The methane is leaking. Methane is worse than CO2. These are the sources of methane. Lower right, enteric fermentation, landfills. The natural gas and petroleum is on the upper right, the largest. Here we go with the cow. The cow is burping methane and pooping manure that has methane in it. There's a farm in Citrus County that catches all of the manure and recycles it through a fermentation process and powers their farm. And the greenhouse gases from combustion. And worker damage, there's always worker damage. All right, oil-powered electric plants. Same as before. Put in something, burn it, make steam. Fewer operations, it's very few in operations, probably due to the oil shortage in Jimmy Carter's presidency. They were converted to gas mostly. Okay, global increase, industry conversion from oil to gas. Increased use of diesel in ships, decreased use of the heavy oils, exploration, increased oversight of fracking. All right, natural gas. We're going to race through natural gas, hopefully in about 10 minutes. If you can sit still for that much longer, I'm sorry. And next week's will also be a long one because we have to go through a bunch of other stuff. So gas seeps up in the middle and we're lit by lightning. The oracle at Delphi was a gas seep and it was continuous flame. The Chinese collected natural gas with bamboo pipes, used it for distillation of seawater. The French explorers saw Native Americans igniting natural gas. Britain used manufactured coal gas for heating and lighting. In Gainesville, since about 1887, we had manufactured gas, coal gas. And there you do destructed distillation, heating in the absence of air of bituminous coal used as a fuel. Sometimes steam is added, and here in Gainesville, they did add steam and increase the yield of the gas. You get out methane and carbon monoxide, and the pipes that were run all around Gainesville were from the Gainesville Gas Company. A little plug for my great uncle who owned it, and his son, my uncle, my father's cousin. Daddy worked there for a number of years up until probably about the early 50s. Britain used manufactured coal gas for heating and lighting. This is the old Gainesville Gas Company main warehouse. It still stands on Southeast 4th Street. You can see it was a brick paved street. That was the front end was the display for stoves and gas refrigerators, furnaces, and heaters. The back end was the workhouse and the area where they could repair and do that sort of thing. The manufactured gas plant is long gone. It was back sort of where those trees are. As you look at the front of the building, it was to the left and back across and further west than where the depot building is. Okay, Baltimore used manufactured gas for heating and lighting in the early 1800s. Fredonia, New York, the first successful natural gas well. Manufactured gas or Philadelphia Gas for municipal distribution of natural gas, and that company is still in business. One of the first audits I ever had for my income taxes, they claimed I hadn't claimed the income from Philadelphia Gas, but I had, and I got out of that one. Robert Bunsen invented the Bunsen burner. We've all seen them in high school labs. It's where you can mix air with the gas to get a very hot flame. And if we didn't have that, none of the gas plants around here would be working. You've got to have just the right mixture of air and natural gas to fire those things at a huge temperature, several thousand degrees, I believe. So production and delivery, you have the gas wells, the water, getting the oil and the water separated, vented and flared. You process it, but look over here. Let me see if I can. Where'd it go? Where'd it go? It disappears. See down here, there's a little square that says odorant. All the natural gas has an odorant mixed with it because when it's processed, you don't smell it, and a lot of people are getting killed. So the odorant is in there for safety reasons. Production and delivery, the wellhead, this is a capped wellhead for a natural gas well. Natural gas production is way up in the US. We are the largest exporter of liquefied natural gas in the world, and we'll see that. It has a boiling point of minus 260 degrees F, so you have to cool it down and pressurize it to liquefy it, but it's 600 times denser, which means you can have smaller tanks and you can transport it by ships. We'll see that. So this is a natural gas liquefaction, wait a minute. Liquefied natural gas manufacturing place. So the gas comes in for pre-treatment and then it has to go through refrigeration and compression. There's some above ground liquefied natural gas going into a ship. And USA is the largest producer. These are the relative producers in 2023, the first half. We are above Australia, which is very high. Qatar is doing a lot of natural gas production, and they're trying to get that natural gas to the European Union, which is a large user of natural gas, since the Ukraine pipeline is shut down and the North Sea, not North Sea, but the Baltic gas line was sabotaged, allegedly by Ukrainian SEALs. Yeah. So there's some question of who blew it up, but everybody knows it was blown up. Cryogenic, you can store natural gas at low pressure, but you have to keep it somewhat cool and keep the pressure up. This is a seagoing liquid natural gas container ship. Yokohama is the import facility in Japan. The liquid natural gas ports worldwide, they're all over the place. There was something recently that the government has not yet approved an improvement in a liquid natural gas distribution plant, which I believe was to have been down in Louisiana or on the Mississippi River. But we still produce the most. We distribute the most to the rest of the world. So transportation, again, it's just pipelines coming from the gathering fields through the processors, the compressors, and into the distribution system here. This is probably a compressor station, but it's a natural gas pipeline facility. Here they are, all over the country, natural gas pipelines there. Look at the one that goes from, I think it's from Mobile to Tampa. That was just put in about 20 years ago or within the last, it's recent compared to our age. Rail cars, again, you've got these big rail cars that can carry liquefied natural gas. Trucks, you've seen these guys. We had a truck like that would come and fill up our RV when we needed it. This is a different, larger truck. Ships, we saw a picture of the ship already. The storage cryogenic tanks, which have to be kept cooled and pressurized. The dome on the left, I believe, is one. The green thing on the right is a gas storage thing, and it is a floating storage device. We had one for the Gainesville Gas Company, had one or two of them that were behind the building I showed you, and it would float up and down, and you could see how much gas was available, but it kept a constant, fairly low pressure on the gas lines. The gas lines went out at reasonably low pressure, and then usually had a reducer in the house or near the house to reduce it down to much lower pressure. They had quarter meters in those days. People that didn't have a gas meter that was read and got a bill from the company had a quarter meter, and you could put a quarter in it and you would get a certain amount of gas and hope that it lasted through your shower. One of the things Daddy did was go around and rob the quarter meters. Pressurized underground and salt mines and unused gas domes, pressurized tanks. This is a pressurized tank, and you see it's got a lot of support to it because I showed you that liquefied natural gas is 600 times more dense than the gas as a gaseous product, so it's heavier, you need more support. Same thing, you got heat, you got steam. This is the combined cycle. So on the upper area, you have a gas turbine that's running. It's connected to a generator, which produces electricity. It has high temperature gas going into the steam generator and going to the one on the lower left that has a generator as well. So there's 4 combined plants in Citrus County. They replaced the nuclear power plant, which Duke Energy screwed up and it's out of service forever. And they put down 2 of the 4 coal plants, and they brought in 4 natural gas combined cycle plants. And I show you these because we can see what the construction of one of things is. So it uses 1,640 megawatt electric, 293 million cubic feet per day, which is enough for 7,300 homes. This is the gas line that came. There was a lot of controversy in Citrus County and surrounding counties about building a huge gas pipeline that was somewhere in the order of 18 to 24 inches in diameter. They have air inlet cleaners. I didn't talk about that earlier, but you need to get everything out of the air, the pollen, the insects, the dew, if it's very humid. So it goes through air inlet cleaners. And the Gulf water cooling, 2 miles of piping, and those are the cooling watered stacks for the steam turbines, part of the combined cycle. So pro of natural gas, convenient, readily available, cost effective, cheaper than coal in production and transshipment, and utilization, burns cleaner, 90% reduction in sulfuric oxides, which is a reduction in acid rain, and nitrous oxide emissions are eliminated essentially. It's non-renewable. Somebody's estimated 40 years left of natural gas. I'm not sure if that's true. It's a number I found, so you get it. It's highly flammable, methane flaring at the wells, methane leaks at all stages of transportation and production. Methane gas is worse by 80 times more harmful for 20 or more years than CO2 and atmospheric pollutant and climate change. Future gradual increase in production, industry conversion from coal to gas, increased use of gas turbines, power production, ship propulsion, Some Navy ships have gas turbines now. Train locomotives, increased exploration and production, fracking, and this is the top 10 thermal power plants: coal, 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 oil, natural gas, coal, natural gas, coal. So the main production of energy around the world are these guys. So someone asked about the comparison of the different uses, and this is in the States. In the 2006, we were getting 2,000 billion kilowatt hours from coal, and it's now down to around 750. Natural gas has increased by more than double. Nuclear is running a little constant or lower, and recycles are a little bit up. So this is in the US. I don't have a graph for around the world. So this is electricity. Here we are, production by source around the world. The very, very top is other recyclables, bioenergy, solar, wind, and coming on down, you can see who's providing the most power and how it is changing over the last 20 years. So next week, hydrogen energy, geothermal energy, biomass energy, nuclear fission, nuclear fusion, bring your pillows. It'll probably be another lengthy one because there's so much to cover, and I'll go as fast as I can. Yesterday on the TV, I heard some woman talking about something, and I told Carol the same thing my mother told Carol one time. You'll have to talk slower. I can't listen that fast. Any questions?
I got a related question. And don't know if you've got a quick picture of the exhaust of the power plant, the shape of this particular choice that they tried to expel the heat vertically in the process. And I'm just curious about the design of that process. You might not know anything about that, but I'm just curious that the design appears to be a shape.
It is a natural, a natural or forced flow up the stacks. And it goes wherever the wind is blowing that day, and you can't really control it. But they are doing a lot of cleaning of the exhaust gases from coal plants now to get out some of the sulfur dioxide and nitrous oxides to cut down on acid rain. And they actually are spraying it down to get the fly ash that might be transported up. And we used to see big trucks of fly ash being hauled away from the Citrus County power plant, and it could be used in concrete production for roads and other uses. You remember, and Jack may remember as well, shortly after the war here in Gainesville, there was a huge building concern because of the GI students coming to the university, and we had cinder block on concrete construction of houses. And the cinder block plant was by Ennis Brothers or Anderson, I've forgotten which. It was down on Depot next to the power plant, so they could get the cinders and whatever else from the power plant and make the concrete and the concrete blocks. So that was one use of it. But a lot of the fly ash is still remaining storage near the plant, and it's a problem. Any other questions? Anybody on Zoom? Oh, there's Marguerite.
The fiber optics, they were laid not many years ago, And that they go all the way down to South America, like Rio de Janeiro, or even further.
Fiber optics are all over the world. They're cheap to produce, relatively speaking. Corning Gas in upstate New York was one of the producers. Um, they're really cheap. They're easy to connect, and each connection has a semi, what do you call it? Little electronic pieces, it's electronics to receive the signal and transmit it further. And there may be even some in the ocean cables partway across, because you can get dispersal of the fiber optic signal because it's optics. It's actually it's light running through the cable, and they've done a lot of work on designing the cables so that they will have less dispersal or spreading of the signal, and thus reducing the capability and the throughput. We have fiber optic coming in here from GRU, and they come to our house. We have fiber optics coming to the house, and there's a transformer for the fiber optics, puts it out in the regular copper cables that we have going to our distribution centers. And I've had a fault with that. A year or so ago, there was a very close lightning. It was like flash boom, that fast. And we started having some problems with our cable and with our internet connection, and got the guy to come out, and he finally had to open up the box in the side of the garage wall and replace that the optics to cable box. It's a very little thing, but it's right there hooked to the fiber optic, and it's also got power from the electrical system. So if the zap comes close to your electrical cable, you're in trouble, and we were.
I have another thing. I still have a coal miner in my house. We used to live in West Virginia, and I have this little statue of a coal miner out of real coal.
Oh, cool. Send us a picture and I'll put it up next week.
For all the tourists and so, they're making it out of some other material now. But my mother used to shovel coal out of her 246-year-old home, and she had to lug it out to her furnace every day.
Yeah, Carol's family were lucky in upstate New York. They had a coal bin, and they had a little pump with the helical. They could run the coal into the furnace without having anybody to do anything there. That was gone by the time I met her, and it's now gas. Any other questions?
Well, my husband at the University of West Virginia, he had a student, and he got killed suddenly by a conveyor coming from the coal mine, and I don't know where it went to, but he was buried alive.
Ooh, so yeah,
Lots of-
it could be going from the coal mine to the rail cars.
Mhm.
So to the Tesla fuel devices. Anybody else? Okay, well, thank you for staying long, and I'll try to go fast next week so you won't have to stay as long. And Marguerite will send us a picture of her coal miner. And I'll see if I can find more of Richard's question about stack gases. Thank you very much for coming.